Hello everyone, welcome all of you. I am Krishna Singh Rajput, and in the series of engineering mathematics we are going to study 6 chapters, and out of those 6 I have taken the first chapter as differential equation, and in this particular session I will be talking about the outline of differential equations, that in the upcoming sessions what we are exactly going to study in the differential equations from gate point of view. So what is an differential equation? So there are two types of them. One can be ordinary differential equation and another one can be partial differential equation. So what does it mean by ordinary differential equation? So in the ordinary differential equations we are going to have one dependent variable, and which is going to depend on the another second independent variable. So we can say if y is the dependent variable and it is depending on x, which is an independent variable. So what does that mean? That only y is going to depend on x, whereas x is independent variable, so it is not going to depend on anyone. So in that case we can write the differentiation of y with respect to s as dy by dx. Whereas in the another case, if x is an dependent variable, whereas y is an independent variable, so the dependent variable x is going to depend on independent variable y. So in that case we can write the differential equation like differentiation of x with respect to y. So in that case we can write the terms as dx upon dy. So this is going to be an standard form of ordinary differential equation. So dy of n divided by dx of n plus k1 dy of n minus 1 divided by dx of n minus 1 and up to kn y is equal to capital X. So this capital X is going to be the function of small x. So where n is going to tell us the order of differential equation, and the whole power of this particular term is let us say y, or let us say some another term p. So the power of the particular term is going to tell us the degree of the differential equation. So this term n is going to decide the order, and the power of the maximum order is going to tell us the degree of differential equation. So from gate point of view, in ordinary differential equation we are going to have the look of first degree. So this particular power of maximum order is going to be 1 always. So we are going to talk about only linear differential equation. So if we are taking the order as 1, so we are going to have first order, first degree, so first order linear differential equation. And in the other case, if the order n is more than 1, so in that case we are going to have the higher order, whereas degree is going to be 1 only, because we are always going to talk about the only linear differential equation. So the maximum power of the higher order is going to be always 1. So if we have the order as 1, so we are going to have first order linear differential equation, and if we have order as more than 1, so we are going to have higher order linear differential equation. So in the first order linear differential equation we have 5 types. We are going to study about the inspection method, and then we will have the look of exact differential equation, and if the differential equation is not in the exact form, we can reduce it in the exact reducible form also, and then we'll have the look of variable separable method and linear differential equation. So all these 5 are going to be the techniques to solve the first order linear differential equation, whereas in the case of higher order, and again the linear differential equation only, so we are going to have the homogeneous differential equation and non-homogeneous. So the term x, which is the function of small x, can be 0. If it is 0, we are going to have homogeneous differential equation, and if that term is non-zero, it means it is going to be the function of small x. So in that case, that is going to be known as non-homogeneous differential equation. So we'll try to understand that which kind of methods we are going to use for them, so that we can come to the solution of ordinary differential equations. So in the ordinary differential equations, I'll repeat, we are going to talk about only linear differential equation and first order or higher order. So moving to the partial differential equation. So in the ordinary differential equation, what was happening, only one dependent variable, let us say y, is depending on another one independent variable only, which we have taken as x. So we have written in dy by dx, whereas in the case of partial differential equation, one independent variable, again let us say y, is going to depend on more than two independent variables. So y is going to depend on x and z, or z is going to depend on x or y. So the dependent variable is going to be one only, but it is going to depend on more than one independent variable. So I have taken the example as z is independent variable, sorry, dependent variable, and going to depend on x and y. So two variables it is going to depend on. So again, in this case, we are in the case of first order, as I mentioned, the power of dou z by dou x is going to be 1. So here you can see the power of z with respect to y is 1, and the power of z with respect to x is also 1. So it is going to be first order. And if we are talking the power of higher order, the highest order in the equation, if it is 1, so it is going to be the linear, and the power of highest order is more than 1, so it is going to be non-linear. So in the case of ordinary differential equation, we are not going to talk about non-linear equation at all, but in the case of partial differential equation in the first degree itself, first order itself, we are going to have the one place higher degree also. And moving to the second order, again the value of n is going to be greater than 1. So in that case, we are just going to have the look of classification only. So we are going to have order is 2, like dou 2z by dou x2, but the degree is 1, right? Because the order which is having 2, the power is 1 only, so degree is 1 only. So in that case, we are going to have the look of just classification, that if the value of v square minus 4ac is less than 0 or equal to 0 or greater than 0, so what will be the shape of the output curve which we are going to get by solving that particular partial differential equation. So this is the basic idea about the differential equation, ordinary and partial differential equation. So in the upcoming sessions, I am thinking of making the short videos. So I'll be having one videos on all individual methods, and few 2-3 problems I'll try to add in them, so that in one particular session we'll focus on one method. So instead of providing long videos, I'll try to make the videos little short. And okay, see you in the next session.